So if you struggled with that, you need to spend a little more time with it, because we have to have our BFFs learn. They're going to follow us all year. And next year, and the next year, whenever you take math, they're going to follow you around. All right, so here we go. Piecewise function. Who remembers, right, we only did one. Who remembers how we did it though? Robbie?
Oh, so you solve them both, and they're both only like one side.
And one side of what? Where is that breaking point in this graph?
So it's at 0.
At 0. So I'm going to put a little squiggly line here that's not part of the graph. But that reminds me that, like Robbie said, that's where the picture splits. Right there. Okay, what shape do we have up here? Who is this guy? He's the reciprocal function. And we hopefully remember that this is the reciprocal function. Right? Now, this line, squiggly line, splits this curve into two pieces. It's kind of already split because of the kind of curve it is, but I've got two pieces to it. This tells me which piece I keep. So which piece will I keep? Look which way the arrow's pointing. Left. So I'm going to keep the left piece and erase the right piece. Usually, almost always in fact, the curve when you draw it intersects your squiggly line. And when that happens, we put a dot there, remember? We put a dot there, and that helps us know which side to erase. This particular curve doesn't cross that squiggly. We just keep the whole left side of it. So this is it. Now what does this one look like? That is starting at the origin, up and out, right? That's your square root function. Now this one does hit the squiggly line, so I'm going to make my dot there. That dot actually is filled in, right? It was already, but I'll fill it in big. And luckily for me, I'm keeping the right side of it because that's all I got to this picture. So this is it. That's your piecewise function.
Okay. Would there, it says like continuities at the top, would there be a vertical asymptote or no? Because it includes 0 on the other one.
It does. There is no vertical asymptote. You're exactly right.
Is that where to go if it was like less than or equal to? We would have to erase it too. Like if
this had been less than or equal to,
yeah,
that would not impact this because there's no dot for this part of the graph.
So we'd have to erase the.
Yeah, that dot would be then over. Yeah. All right, one more. This one's a 3-parter. Okay. Well, what's a little bit different about this one now then? What's going on over here?
Oh,
There's two separators, two squiggly lines. So we're going to have a squiggly line at 0 and a squiggly line at 1. The graph has separated two places, which is okay. It makes sense because it's a 3-part problem. So we're going to have something over here, and something in the middle. Would you agree with that? Seems logical. All right, so what are we going to have? What's this? What shape is that? Think of it as the equation, negative x minus 3. What shape is that? It's a line. It's a line. It's going the opposite direction because of the negative, and it's been moved down 3. So move it down 3. run it this way. Does that make sense to you? It's a line with a slope of -1 and a y-intercept of -3. Now, I have 2 squigglies. But for this particular curve, I only care about where it hits the 0, right there. I don't care about where it hits this one. That's not part of that equation. Open dot or closed dot? Close. And because that's going that way, I'm gonna keep this and erase this. So far, my picture is this half line, or whatever you wanna call it, right here. All right, now the next one is not really a BFF. It literally says y equals 1. Anybody know what y equals 1 looks like? Horizontal line through 1. So there's y equals 1. Look here though. This one involves both squigglies. So I'm gonna have a dot there and a dot there. And both of those dots will be open. And what am I keeping? The middle. I'm keeping the part, look where that X is sitting, guys. It's sitting right between 0 and 1. So I am keeping the part between 0 and 1 and erasing all of the rest. So I've got this black thing shooting up. I got this little pink piece right here. And now I'm going to do this. What's that? That's a parabola. Vertex at the origin. Oh, my markers are running out. All right, so there's my parabola. Now, keep in mind, this is the point 1, 1. This was 1, up 1. The parabola actually contains the point 1, 1. So it goes right through that pink dot. Does that matter to me? I don't know. I care about where it crosses that squiggle. That would be right here, right? And it's or equal to, so I'm now gonna color that dot in. And I'm gonna keep this piece of it and get rid of the rest of it. I will never mark it wrong if you don't erase your squiggle, but we really don't need it as part of the graph. It's not really part of the graph. So what have we got? We got this black thing shooting up like this. We have this little pink thing where this dot is open, but that one got filled in by the purple. And the purple's turning up like that.
So why is the dot on the straight line with one on the left, why is that one open?
Because it came from right here,
Okay,
and there's nowhere equal to on that, unless I copied it wrong.
I thought that the one above it was, does it count for all of them? Like if the one before it said X is less than or equal to 0?
Okay, this applies to this middle part of the graph only. That applies to this.
Okay.
So for the top line, you only look at the top line.
Okay.
When you do the middle line, you only look at the middle.
Oh, okay. I got it.
And if you think about it, Allie, if I colored this in, this would not be a function.
Oh, right.
Yep, we have to be a function. So you're never gonna have 2 closed dots on top of each other, ever. Okay? Well, like I said, I feel like we got some missing things. So I'm gonna give you a couple things today. One is a review sheet that we're not using today. So I'm giving this to you now, but I want you to put it away, keep it safe. And then I'm gonna give you a little review thing that we are gonna work on today. Yeah, 1.3 will be due on Monday. You can always turn it in early if you think you'll forget on Monday. Okay, did everybody get one of those? Please put that away. This is what we're gonna work on today. One of the benefits of having done this so long is I just have so many old resources. So I went back and dug up a bunch of stuff that I thought would help us review. So you probably aren't gonna have time to do all of this today. Here. All right. Did everybody get one of these?
Speed.
Yeah, that's an activity. We're not speed dating. That's an activity. We are not speed dating. This was a speed dating activity. At some point, we will speed date, but not today. All right. So what I'd like for you to do, and some of this doesn't pertain to us. So I'm on the very first page, right top of the little packet I just gave you. You can cross off number 1. But number 2, we need to be able to do. And this is one of those things where I can't remember if we even went through this. So we need to get our calculators out. And some of you are really, really good at looking at the data and coming up with an equation. Some of you are really good at that. I want you to notice something. Look at your x's. They are going up by 1, right? This y is going up by 11, but this one is going up by 15. If you have a linear set of data, in other words, if your equation is going to be a line, the ratios will be the same, because that's what slope is, right? The change in y or the change in x will be the same. So this data is not linear. So your equation is going to be an x squared. Now, you can play around with it and try to figure it out. That will work, and some of you are, like I said, are good at it. Or we can use our calculator, and I want you to be able to use your calculator. So I apologize if you've never done this before. We're doing it now.
Can you explain again why it would be an x squared?
Well, because the only kinds of regression we've talked about are linear and quadratic. So it could be other things, but we're only going to do linear and quadratic.
Okay, then why wouldn't it be linear?
Because
the slope's
the
not
slope's not the same,
Okay.
right?
Yeah.
Okay? All right, so here we go. Now, go to Stat and choose Edit, which is the first option. If you have stuff already in there, you can clear those out a couple of different ways. One way is arrow up and highlight the name of the column. So if it says L1, highlight that and press clear, and that will clear out L1. And then highlight L2 at the top, press clear, it will get rid of that. Now, put in your L1s. Put in your L1s. 1, 2, 3, 4, 5. Put in your L2s. 4, 15, 30, 49, 72. Once you get that last one, and make sure you hit enter to set it in there. And then second, quit. Go back into Stat, go over to calc. Choose quadratic regression. We are only doing quadratic and linear at this point, so choose that. If you have a new calculator, you have to kind of scroll down through till you get to calculator. So you go to second calc. Actually, yeah, no. So go to stat, over to calculator, and you have to scroll down to calculator. If you have no calculator like mine, you go to stat, calc, quadratic regression, and then you have to put in L1, comma, L2. And the equation that you should come up with is 2x squared plus 5x minus 3. 2x squared plus 5x minus 3. Did you get that? Yep. Yep. Remember, your quadratic is ax squared plus bx plus c, so they give you an a, b, and c value. Did you get it, Emma? Perfect. Okay. All right, we only have a couple minutes to answer these in case. Right here, L1. Okay. All right. Office hours, if you're struggling a bit with that, as we don't have time to come back and do another one today, which I don't know if we will or not. So there's my equation. Second question, how many calories will you burn if you work on math for 8 minutes? Well, when you set up your equation, the x's were the minutes and the y's were the calories. So if we want to know, or if we know we're working for 8 minutes, where are we putting the 8? In for x. So you're just going to figure out what this is, and that's going to be the answer to the question. 165? Is that wrong? Right? So 165 calories. All right. Back to our calculators. I want you to graph this guy. So your regular graph. So y equals 4x to the third minus 7x minus 9. Just hit graph. Remember, if you don't see a shape like you think you ought to see, you can make window adjustments. I'm just going to zoom square, so zoom 6. Zoom standard, zoom 6. I'm still not liking that because if you zoom 6, does yours look kind of like this? Yeah. And I'm missing the bottom part of my picture. So what do you think I might do if I'm interested in this bottom part? Change my window. And what do I need to do to my window? I need to make my y's go down farther. So y min maybe will be negative 30. Oh, that works. I just changed my y min to negative 30, and now I see a picture that looks like this. Is that what you see?
Yes.
All right, so zeros, remember, are x-intercepts. This is a zero. You know how to find a zero. How do we find that zero? Second, calc, choose zero. And then left bound would be over here somewhere. Right bound would be over here somewhere. And did you get 1.74?
Yeah.
Perfect. Now on my calculator, it has that x value, and then it says y equals negative e minus 12 or something. Did yours do that, or is it just mine? Okay, that's the same as zero. So don't let that alarm you. When you get something like that with an e minus whatever, that just means zero. It's a round off error, just zero. Don't worry about it. This is your zero. Now, this particular problem asks you to find the maximum and the minimum. Guess what? We do it the same way. So let's find the maximum first. Second, calc. This time we'll pick maximum, right? And then it says, okay, what's your left bound? We'll set it over here somewhere. Left of the point you're looking for. And then right bound would be over here somewhere. And what did you get for your maximum?
-0.76.
Comma, maybe 0.544 or something like that. That's my maximum. How do I find my minimum? Second, calc, minimum. Oh, I got positive 0.76, negative 12.56. Is that okay with everybody? So, that whole problem, while it's asking 3 different questions, you find them all exactly the same way. Second calc, max, min, zeros. All right, find the domain. What about that first problem? What can you tell me about domain? What? Can't be 1. So whatever it is, it can't be 1. I'll deal with that in a second. What else? 4x minus 8 has to be bigger than or equal to 0, which means x is bigger than or equal to 2. Right? So now I need an interval for this. This is very confusing for me. So I'm going to go ahead and, oh wait,
It's kind of odd.
it's kind of odd, isn't it? But that's
Yeah.
okay. It's all right. This is what happens when Mrs. Ford just randomly makes stuff up. This happens. So this is x bigger than or equal to 2, right? This is, oops, x can't be 1. But if x has to be bigger than 2, then I don't need to worry about this, do I? So my answer is 2 to infinity. Usually what happens when your teacher is responsible and rigs it appropriately, usually what happens is, like something like that, in which case you say everything from negative 2 to 3, and then everything from 3 on. But this time the opening is not even part of the possibilities, right? So yes. How about B? And we're not gonna say all real numbers, we're gonna say negative infinity to positive infinity. But it is indeed all real numbers because there's no radical and no denominator. All right. This is a monster problem. All Alright, so tell me what I ought to do. First of all, please don't cancel anything.
Fact.
Yeah, you cannot cancel until you have factor. Okay, so don't say, oh, these are canceled out, oh, those are canceled. No, nothing cancels, but I think we can factor. I can actually take a 2 out of the top. And then how does it factor if I take a 2 out of the top? X minus 4, X plus 1, perfect. How about the bottom?
-4, -2.
Minus 4, minus 2, oh my gosh, what do you notice?
Cancel.
There's a hole, we're gonna have a hole in the picture, right? It cancels. Remember, the only way to get a hole is to have something cancel. Well, we had something cancel, so we are gonna have a hole. Anybody remember where it is?
4.
It's gonna be where X is 4. If the hole is a point, okay, so it's a point on the graph, so it needs a Y. How am I gonna get the Y?
You plug in X for that. Like you
Plug
plug it in.
Four.
Yeah.
So it'll be 2 times 5 over 2, so 5. Now what about vertical and horizontal asymptotes?
2 for the horizontal.
The horizontal is 2, I heard somebody say it, because why? I like to look back at the original right here. But you can also look right here if you want. Can you see that horizontal is at Y equals 2? And what about, oh my, where's the vertical?
2.
It is also at 2. Make sure when you name your asymptotes, they are equations. So make sure that your Y equals X equals. Okay? Is the function drawn below bounded? Oh, you can, we haven't done the intercept part yet, so just cross that off, don't worry about the intercept. You need to be able to find the vertical asymptotes, the horizontal asymptotes, and the holes. Okay? That's what we need to be able to find. Is the function drawn below bounded? Yes. Explain. Its lowest point is 0, 0, right? And if you have a lowest point, you have a bound. That's what a bound is, a lowest or a highest point. So bounded below at 0, 0.
If we wrote like on a test or quiz that the reason is because it has like a floor
Yep,
or ceiling.
perfect, that's my language. Of course I'm gonna love it. Now, if you do that next year, who knows what will happen to you. Which function is pictured in number 6? This is your BFF knowledge. Which function? Absolute value. Yep, absolute value. Alright,
I have a question.
I see I ran off the same page twice, what?
On number 5, what were the X and the Y intercepts?
We haven't done those yet, so I'm not worried about it right now. We're gonna do those, I promise. You just, intercepts are when the X is 0 and Y is 0, so you just plug them in, we just haven't done it yet. Alright, I need you to look at, the very back page is an old practice quiz. I wanna highlight, we're almost out of time, I wanna highlight a couple of problems here. Number 1 on this old practice quiz. Is this function even? Why or why not? How do you tell if something is even? You test for symmetry to the y-axis. And what is the test for symmetry to the y-axis? Change the sign on x. So if I make this a negative x, I'm on the last page. Last page, first problem. Is that the same equation? So question is it even? The answer is yes. Why? Because it has symmetry about the y-axis, and that's what even means. What if it had said, is it odd? Then you would do the same exact thing, but you would test for symmetry about the origin, which is changing the sign on both. I think this one's also odd. Can I change the sign on both and be okay?
Yeah.
Katie?
What did you say our reason should be for why? Is it just because
It's symmetric about the y-axis. We tested for symmetry and it passed. Number 2, identify with words or an equation. So in other words, what am I looking at in number 2? Square root function, right? So you can either say square root function, or you can say y equals square root of x, right? That's one of your BFFs right there. Number 3, name a BFF with this end behavior. All right, so what this means is, have we talked about this notation?
No.
All right, good, we need to. It's calculus notation, we definitely need to talk about it. So what this means is very, very simple. X is going to infinity, so think of your graph. Where does that happen? Where does X go to infinity? Out here, right? So this basically says go right, right? This says go left. Now that's your X direction. F of X is the same as Y. So this is saying Y is going to infinity. So when Y goes to infinity, that means it's going up, right? Y is up and down, so this is up. This says Y is going to negative infinity, so it's going down. So you gotta think of your BFF pictures. Which pictures are drawn so that as you go right, you go up, and as you go left, you go down. So there are several, so there isn't just one, there are several. Allie? Cubing. Cubing absolutely does that. As you go to the right, don't you go up? As you go to the left, don't you go down? Right? So that would be one. Can you think of another one? You only have to name one, but can you think of another one? Linear, for sure, linear. How about greatest integer? As you go to the right, are your steps going up? How about as we go left? They're going down. So we have the identity, we have cubing, we have greatest integer, and there's probably some more too, that we don't have counted yet. All right, we already did one like 4, we already did one like 5. Okay, 6, I'm still on this practice quiz. Sketch, y equals sine x. What do I have to remember about sine? Your graph doesn't have to be perfect, but what do you have to remember about it, Allie?
It's all between -1 and 1.
It's all between -1 and 1, and it goes through the origin. So it's these ups and downs, hills and valleys, but it's gotta go through the origin. Y equals x cubed. Didn't I already draw? Domain. I'm looking at this wild and wacky picture in number 7. What's its domain? Can you tell from the picture? You don't have an equation. Can you tell from the picture? Is it negative infinity to positive infinity?
Mm-hmm.
Be careful with the range though. What's the range? -2 to infinity? Perfect.
Would it be -2 in a parentheses or a bracket?
Bracket, because you have points at -2, so it would be bracket at -2. Is it at all increasing anywhere?
Yes.
Where is it increasing? Well, increasing means going up, right? So start drawing it. Aren't you going up on this little section right here? Okay, so it starts at -3 and it goes to -1. In that little span of time, I'm going up. As I move from here to here, I'm going up, right? Remember, I'm drawing left to right. Where else am I going up? From this point forever on? So how would I say that? 3 to infinity? Now, I'm not gonna quibble. If you wanna put brackets around these, you can. Not around the infinity, but you can have brackets or parentheses around those. That's where it's increasing. Does that make sense to everybody as you look at the picture? What would 8 look like if we sketched it? Please tell me you know what 8 looks like if we sketch it. It's a parabola with a vertex at -1, -2. It moved left 1 and down 2. Is this thing symmetric across the line y equals x? Why or why not? So what's your test? So x equals -y plus 4. Now we gotta figure out if that's gonna be the same equation. Right, so let's see, this would be x plus y equals 4. So y equals negative, oh my gosh, is it?
Yeah.
It is. It does have symmetry about the identity line. Because when I switched the variables, which is how I test for y equals x, I got exactly the same picture. Okay? So we didn't get through a bunch of it, but we got through a lot of it, okay? So, on tomorrow, we're gonna have another little quiz, which we will not use note cards for in any way, shape, or form, and it will be over the stuff that we just talked about. So I'm gonna write a quiz over the stuff that we just talked about. If any of that is confusing to you, then you need to in here tomorrow morning, so we can get your issues cleared up. No, we're gonna have, every problem we did in that little packet. Yep, in that packet right there.
Only if we did it though?
Huh?
Only if we did it.
Only if we did, yep. So, any problem in the packet that we actually did today, okay? So any problem that you, hopefully we're writing things down, any problem that you wrote stuff down for, that could be a quiz question. It won't be all that, because that would take all period. And we haven't gotten our test back yet, we gotta get that back. That's something. I'll put that in the place. And I will have these on my hands, and then I will. Okay. All right. All right, so we are all set and ready to